Thank you, Jonathan. Before we get on to presenting the findings of the IPCC Sixth Assessment Report on the physical science basis of climate change, I'm proud to unveil the artwork that is featured on the cover page of the report. An artist created this piece of visual art on this front cover, having been inspired by a scientific figure in our summary for policymakers. This global view highlights one of the most important messages from this report, that climate change is already affecting every region on our planet, and every fraction of additional warming will increasingly affect every region in multiple ways.
The IPCC does not conduct new research itself. Instead, the hundreds of scientists who worked on this report come together to assess the current state of knowledge of the science of climate change. They reviewed over 14,000 studies, massive amounts of data. In this assessment, we welcomed the new authors, 2/3 of whom had never been involved as authors of previous IPCC reports. Our team was made up of scientists from 66 countries around the world. In the review process, 3 phases of review by governments and experts, we took on board over 78,000 comments from experts and the governments. All review comments are addressed by the authors. And because of the pandemic, these meetings moved online, and we had to invent an entirely new way of working, which ended up in this unprecedented online approval process over the last 2 weeks. People said we couldn't do it, but we did.
Since the last assessment report in 2013, there have been important advances in climate science worldwide. During these years, climate scientists filled in gaps in observations of past climates. They improved climate models and developed new ways to combine many types of evidence. As a result, today, we have the clearest picture of how the Earth's climate functions and how human activities affect it. We know better than ever how the climate has changed in the past, how it is changing now, and how it will change in the future.
Of course, we have known for decades that the world is warming, but the recent changes we have seen in the climate are now widespread, rapid, and intensifying. Some of the changes we see today are unprecedented in thousands of years or never seen before. The recent rate of warming is unprecedented in at least 2,000 years. To measure how the climate is changing, we looked at a key indicator, the average temperature of the Earth's surface over a period of at least a decade, compared to the average in the late 1800s. If we took at the last 10 years, the average surface temperature was 1.1 degrees Celsius warmer. In fact, each of the last 4 decades has successfully been the warmest since the late 1800s. Temperature is not only aspect that is being altered. Levels of heat-trapping gases in the atmosphere continue to increase fast. Current CO2 concentrations are the highest they've been for at least 2 million years. Over the past 100 years, sea level has risen at faster rates than it ever did in at least 3,000 years. Some Arctic sea ice area is at its lowest in at least 1,000 years. And the retreat of glaciers on global scale since 1950 is unprecedented in at least 2,000 years. The warming we have already experienced has far-reaching consequences. Climate change is contributing to increase in extreme heat, heavy precipitation event, and the drought. Since 1950s, hot extremes, including heat waves over land and the marine heat wave, have become more frequent and more intense. Heavy precipitation events have become more frequent and more intense. And we see increasing drought in some regions. These consequences to heat, rainfall, and the drought touch our whole planet, not just people, but also plants and animals, both nature and agriculture. The growing season of plants has lengthened on average in large parts of the Northern Hemisphere. Fire weather, the combination of dry, hot, and windy conditions that is conducive to wildfire is becoming more frequent in many parts of the world. Multiple changes are taking place in ocean, which is warming, acidifying, and losing oxygen, affecting ocean life and the people who depend on it.
There will be further warming in the coming decades. What is clear from this report is that unless there are immediate, strong, rapid, and large-scale reductions in greenhouse gas emissions, limiting global warming to 1.5 degrees Celsius will be beyond reach. The report shows that in the next 20 years, global warming, the average temperature at the Earth's surface over a period of 20 years, is expected to reach or exceed 1.5 degrees Celsius above the late 1800s. However, if we rapidly reduce greenhouse gas emissions, if we can reach global net zero CO2 emissions around 2050, it is extremely likely that we can keep global warming well below 2 degrees. If we do this, it is more likely than not that temperature would gradually decline to below or around 1.5 degrees Celsius by the end of the century, with a temporary overshoot of no more than 0.1 degrees Celsius. But if global greenhouse gas emissions remain around today's levels in the coming decades, we would reach 2 degrees of global warming by the middle of this century. With every additional amount of global warming, we will see greater changes in the climate. Every additional half degree of warming will cause increases in the intensity and frequency of hot extremes, heavy precipitation, and drought. At 2 degrees of global warming, heat extremes would more often reach critical tolerance thresholds for agriculture and human health. At a global scale, extreme daily rainfall events intensify by about 7% for each additional degree Celsius of global warming. As you see, future further changes depend on future human influence. Now, Panmau, let's go back to where we are today.
It is disputable that human activities It is indisputable that human activities have caused and are causing climate change. That what's new in this report is that we now have a much more advanced understanding of the connections between the emissions we release and the rise in global surface temperature and the change to weather and the climate we are seeing around the world. It is unequivocal that human influence has warmed the atmosphere, ocean, and the land. Almost all the observed warming from the late 1800s is human caused. In this report, we looked at all the atmosphere gases that affect the climate. We confirmed that human-caused emissions of greenhouse gases are the main driver of global warming. And we can see clearly how much warming comes from carbon dioxide, methane, and other greenhouse gases. We can also assess the influence of pollution particles that called aerosols, which have an overall cooling effect. This cooling effect partly masks the warming from the greenhouse gases. We also looked at all the natural factors that can affect the climate. We take into account how natural climate variability modulates human-caused changes at the regional scales with little effect on global warming at the central scale. Another major advance in our understanding of human emissions is how our emissions lead to specific changes in the climate, including extreme weather and climate events. We know today that human influence is already making extreme weather and climate events, including heat waves, heavy precipitation, and the droughts, more frequent and more severe. Hot extremes, including heat waves, have become more frequent and more intense since 1950s, and some recent hot extremes in the last decade would have been extremely unlikely without human influence on the climate system. Furthermore, we know that human influence has been the main driver of ocean warming since 1970s, and that human-caused CO2 emissions are the main driver of ocean acidification. Human influence in contributing to reduced oxygen levels in the ocean observed since the mid-20th century. Human influence is also the main driver of change we see in the frozen areas of the planet, the cryosphere, driving the global retreat of glaciers since the 1990s, the 40% decrease in Arctic sea ice since 1979, and the decrease in spring snow cover since the 1950s. It is very likely that human influence contributed to surface melt of Greenland ice sheet in last 20 years. These advances in our understanding of how human activities are affecting the climate mean that today we can better estimate the change we may experience, both gradual trends and extremes, resulting from different amounts of emissions, different levels of warming, and across different regions. Climate change is already affecting every region on Earth in multiple ways. But climate change manifests differently depending on where in the world you are. There are different combinations of changes in every part of the world. In this report, we added more new information that is useful on a regional scale. This is an area of climate science that has rapidly advanced in the last 10 years. To reflect this and provide more information helpful to inform decisions, related to risk management and adaptation. Around a third of our report is dedicated to regional climate information. As a part of our focus on regional climate information, we also introduce a new concept of climatic impact drivers to help translate physical changes in climate, heat, cold, rain, drought, snow, wind, coastal flooding, and more into what they mean for the society and the ecosystems. We are not only looking at gradual temperature increases, but also at the specific conditions where heat goes over thresholds known to lead to severe consequences for people, agriculture, and wildlife. Many of the changes we assessed are related to the global water cycle. The water cycle means how water moves through the atmosphere, land, ocean, and the cryosphere. With warmer temperatures, the atmosphere can hold more water, and we see more and faster evaporation and heavier precipitation. The monsoon rainfalls, which are also important to so many peoples, are changing in complex ways in response to the contrasting effects of both greenhouse gases and the pollution particles, which we call aerosols. With more global warming, the global water cycle will intensify. That means both heavy rainfall at the same time as we see intensifying drying seasons and droughts. With more global warming, average annual rainfall on land is expected to increase, but that rainfall is expected to become more variable within a season and from year to year. The interactive atlas launched today makes our global and regional climate information available to all. It includes observations of ongoing changes, the projections of future changes. And you can see the interactive atlas to make your own maps. You can use interactive atlas to make your own maps and analysis using the datasets we used in the report. You can use interactive atlas to find out what climate change means for where you live. Valerie, back to you.
Thank you, Pan Mao. Moreover, many of the changes set in motion by human-caused climate change are slow processes. These long-lasting changes, for most part, affect the planet's frozen regions, the cryosphere, and the ocean. Changes in ice sheets, deep ocean temperature, and acidification will continue for centuries to thousands of years, meaning that they are irreversible in our lifetime and will continue for generations to come. In this report, we show that over the course of this century, global ocean temperature is projected to rise 2 to 8 times as much as it has increased since the early 1970s. The melting of the Greenland and Antarctic ice sheets will continue for thousands of years. This means that sea level will keep rising. Coming back to today, the rate of sea level rise keeps increasing, and the rate of ice sheet loss has increased by a factor of 4 in the past 30 years. The good news is that these irreversible changes can be slowed down with rapid, strong, and sustained reductions in emissions. And other changes can be stopped if greenhouse gas emissions are deeply reduced. For example, retreating glaciers and Arctic sea ice will continue to decline for at least several decades. But these changes could be slowed and stopped if emissions are reduced. To limit global warming, strong rapid and sustained reductions in CO2, methane, and other greenhouse gases are necessary. We know that CO2, carbon dioxide, is the key greenhouse gas driving climate change. We know it comes, from the most part, from the burning of fossil fuels. This report reaffirms that there is a near linear relationship between the cumulative amount of emissions of CO2 in the atmosphere from human activities and the extent of observed and future warming. This is physics. This means that the only way to limit global warming is to reach net zero CO2 emissions at the global scale. Every additional ton of CO2 emissions adds to global warming. Our report gives more details on how reducing emissions will affect the climate. For instance, it quantifies just how much more CO2 we can release and still have a chance to limit warming close to 1.5 degrees Celsius or 2 degrees Celsius. We know that today, around half of our CO2 emissions are taken up and stored by plants, soils, and ocean. We assess how these processes change with future emissions. And we know now that if we release ever greater amounts of CO2, these natural carbon sinks would actually take up a smaller proportion of our future emissions. This report also shows that while CO2 is the dominant greenhouse gas related to human influence on climate, and reaching net zero CO2 is required to limit global warming, strong reductions in other greenhouse gas emissions are needed. Amongst these, methane reductions, together with strong air pollution controls, would benefit both the climate and improve air quality. Our planet is warming, and it is warming quickly, with increasing consequences everywhere. This report is clear that it is possible to limit future warming within a few decades. The climate we experience in the future depends on our decisions now. Thank you.